So welcome everyone. Thank you very much for joining us for today's webinar. My name is Ifi Mavridou, and I'm the lead affect scientist at Emteq Labs. I will also be your host for this webinar. Today with us, we have Dr. Mohsen Faturecci and Sophia Cox, who will co-present the webinar. Sophia and Mohsen, please feel free to introduce yourselves.
Hi, I'm Mohsen Faturecci. I'm lead hardware engineer at Emteq Labs.
Hello, I'm Sophia Cox. I'm an affect researcher at Emteq Labs, and I'll be showing you the OCOsense app today.
Fantastic, thank you very much. So we're excited to introduce to you our latest innovation, the OCOsense glasses, and the mobile app that goes with it. So in today's session, we will dive in showing you live how the glasses work and what's the mobile app's functionality and how it can benefit your work. Okay, so now we've gone through the outline, and now without further ado, let's turn the time over to Mohsen, who will tell us a bit more about the smart sensing glasses.
So I will start with giving a little bit background around Emteq and where we started our sort of technology journey, ending up where we are now. So at Emteq, we are providing technology for real-time emotion sensing and analytics. We've always been interested in measuring and interpreting facial muscle activation. And we started this journey by integrating EMG sensors into a facial mask. And that allowed us to collect data in a controlled manner, especially regarding the locations of the sensors for different users. And then we looked into taking this technology inside a VR environment where we can also collect that facial expressions and also monitor and control the stimuli that's presented to the user. This allows us mapping of emotional responses to known stimuli. This work on EMG is based on research that has been going on for almost up to 30 years around the ideas of facial tracking and expression monitoring. And we've leveraged the work we've done in developing those EMG devices into taking the next step of bringing these measurements into a real-world scenario, where we could map the context of the environment into these expressions. And we've done this through introducing these sensors into a smart glasses format. The sensor locations in these glasses are based on similar locations to the EMG sensors that we've used in the past. And in turn, we expect to collect the same data locations as our previous work. So I'm presenting you the OCOsense glasses with built-in sensors for facial muscle activation tracking. These provide three-dimensional facial movement mapping. A little bit more into the individual sensing element within this smart glasses. We have 9-axis IMU, which allow for activity tracking in terms of the state of the physical user, such as running, standing, and sitting. These are a lightweight pair of glasses, which allows the user to wear them for long data collection sessions. We also include haptic feedback and LED indicators to provide feedback for the user for the states of the glasses themselves. These glasses can be equipped with prescription or plain lenses, depending on the preference of the user, and the data is transmitted to an iPad using Bluetooth, so the data can be transmitted in real time. We have also included sound detection microphones to allow for adding further context into the surrounding environment. Last but not least, these glasses come with expression sensors, which allow us to monitor the facial activations of the user.
Fantastic, thank you. So just a quick parenthesis here. What we are tracking are facial expression and muscle activations. It's the same approach that we've been using with EMG in the past. We're now doing it with optical sensors. So what exactly are we measuring? In this case, we're measuring the skin movement and deformation that is caused by the underlying muscle. So facial expressions and those configurations are made when the muscles are contracted, and this is due to the motor nerves being activated, sends a signal, and that creates a contraction of the muscle, which is reduced in size and in volume, and therefore changing the overall surface of the skin on the top, and that can be seen as a movement of the skin, but the underlying nerve parameter is the contraction of the muscle itself. So this creates protrusions and wrinkles and changes up on the X, Y, and Z axis for the different locations of the skin. And this is what we're measuring with the optical sensors. And I'll give it that back to Mohsen to explain more about those sensors.
So how do we detect these facial expressions? So this is based on the work we've done in developing our preparatory sensors. We investigated a range of sensors, including proximity sensors only, or capacitive sensors, or type of flight sensors, but none of them gave us the accuracy of the measurement that we needed. So to more accurately measure and monitor the movement of a skin, we realized we need to combine the Z-axis movement, that's the proximity of a skin and changes in the surface, with the lateral movement of X and Y of the sensors, of the skin itself, and combining them into a three-dimensional measurement, which would be allowing us to track X, Y, and Z movement. Now, we will be opening up this technology for partners to integrate this further into their system, as well as presenting them within our OCO glasses. So individual sensors provide individual monitoring of specific areas, but to track the full face and understand what expressions are being performed at the same time, we want to be able to track multiple locations on the face. And the current sensors cover various sections on the face, such as both cheeks, temples, and multiple locations on the brow. Combining all these sites together and the data that we collect from these individual sensors enables us to collect and monitor various facial movements.
So to assess the performance of the OCOsensors compared to the gold standard, which is EMG, we've run a validation study. We have got a short video segment here for you to see, where all the data streams from the EMG, OCO, and from a very high resolution camera are being shown. All three methods were used to detect a brow raise, so the same region of the face. And I'll play you the video. There we go. So with the blue line, you've got the EMG signal. We can see that the onset of the expression is starting early on, and we can see a slight reduced over time. This is due to muscle fatigue, and then we have the offset of the expression. With the orange line, we can see the OCO sensor output, which is activating and being extremely accurate as the camera at picking up the onset of the expression, a little bit delayed after the EMG. Both of those, as you see, they're staying true to the skin movement, whereas the EMG is showing the activation of the muscle underneath. So you can get the understanding of when the muscle is moved, when the muscle is activated, and the skin is moved, and is accurate in different intensities of expressions. So what can we detect really with those sensors? So we've got facial skin movement that we can detect directly. We've got facial expressions. Those can be, for example, smile, frown, and brow raise. We can get the intensity of those expressions. And because we apply them on the left and the right-hand side, we can get also the asymmetry level. From the IMU, the 9-axis smart IMU sensor that we have, we can extract head movement and rotation. We can also infer activities via our machine learning models, for example, standing, moving, walking, etc. And we also have context-aware data output, so further insights. Those include, as you may already know, valence that we had in the past as well, a way of determining if a response was positive or negative along a continuum. We've got attention, we focus on the context, as well as engagement, the emotional and attentional engagement to the stimuli. We have also included sound detection in this version of the classes that allow us to distinguish sound from the user from external sounds. And Sophia will now show us the demo of the OCO app and the functionalities that are included within it.
Yes, so the OCO app's currently running for iOS and is in conjunction with the smart glasses. This presents a comprehensive solution for real-time facial data collection. So I'm now going to share my screen.
So the core functionality of the app is around allowing the users to monitor the status of the glasses, making sure that they are connected, the data is coming through correctly, and also for them to have a way of monitoring the signal quality itself. And also it's a way for the user to set up project, which Sophia will go through and show us.
Okay, so now the app is open and ready to collect data from the glasses. So I will simply turn on the OCOsense glasses by the button on the side. So make a light flash on the inside of the glasses, which will be visible to you while you're wearing them. You then simply go to the Bluetooth symbol in the top right-hand corner. Wait for the device, select it. And yeah, now you can see the Bluetooth connection on the right-hand side is excellent. Put these on, looks stunning. Yeah, that's a step. Okay. The light is flashing blue and I can see it. And I'm now going to give you just a quick view into some more settings. So you can check your battery percentages, your Bluetooth connection, Wi-Fi connection, and storage on the device that you're using. So let's set up a quick test study. So everything within the app is streamlined to make the data collection procedure easier and also completely customizable by the researcher. Once you've named your project, you can add some tags. These are tags that you can use to differentiate between participant groups or features of participants. So for example, we could have a clinical and a control group. And then we could also have tags for female and male participants. Okay. Now we've set up the project, we're going to add some tasks. So we have data choices on the left. You can choose to have just sensor data or present the participant with video footage, text, images, and the option to add labels to your data. Now we're just going to collect video and then also the front-facing camera. As mentioned, we have the optional analytics on the right-hand side here. And once this is done, you can create your participant. We have participant 1, control, and female. And that's how simple it is. Going through. So once you've set up your participants, selected the tags, the first thing you have to do is a quick calibration. While I go through the calibration procedure, one of my colleagues is going to tell you a bit more about why this is important.
So to ensure precise collection of the data, the OCOsense app provides the users an option with calibrating the sensors. Now, this procedure will take you through various expressions, in this case, a smile, frown, and eyebrow raise. And each expression, you have to do 3 iterations of it. And this is so that we can collect the shape and also the maximum intensity of your expression. Now, it's important to provide the maximum expression as the user can do, because then we'll use that data when looking back and analyzing your data, so that make sure we can provide feedback as to what expression happened at what moment, and also what was the intensity of each expression. Now, it might be possible to collect that data without those expressions, but then without those calibrations, but if we were to do that, the problem would have been that we can't run any analysis further, because then we cannot collect at what point what expression has happened. So this helps us with our auto detection for our algorithms. We also have a sensor view for the raw data. In this screen, you can see the IMU pressure sensor, and the IMU simply provides the movement information in terms of accelerometer, magnetometer, and gyroscope movement. We can also look at the individual proximity sensors. And what's important here is then you can, if the person who's wearing them provides, for example, a smile expression, then you can see how that smile will affect the output of individual sensors. And individual sensors are named in terms of their location, so you can understand how they correspond with each area on their face. We also provide the output of the navigation sensors, which is the monitoring of the X and Y movement. So for example, if the user is doing a frown expression, in this case, you can see how the sensors behave on the brow region. On the left-hand side of the screen, we have a status view. That view tells us whether the glasses are ready to use or not, and whether any of the sensors are out of their range. And if the sensors go out of their range, they will turn red, meaning the glasses are not ready to be used. Therefore, the person has to fit them on their face and make sure they are sitting correctly on their face. Once the expression calibration is done, we provide an avatar to test that. So if we perform any expressions, the avatar will mimic that expression for us, smiling, frowning, and surprise, and will display the intensity and the expression that is intended.
Okay. Once you're happy that your participant has calibrated themselves fully and that your data is connected and all the sensors are in the right place, you can move on to collecting your data for your study. So for our first task here, going to go video player and camera. The app streamlines this data because as it's all collected at the same time, it means you have a coherent and collated data stream. Hi. It's very easy to upload media files from your iPad. Simply select, name it, record. It's a quick example. One more thing, as previously mentioned, the app also allows you to annotate and add labels manually throughout your data collection anytime you wish, and these are completely customizable. So it gives the researchers lots of power. Okay, so from here, you can add a category of something that you might want to annotate throughout the data collection. So for example, you can go for movement, and within that, you can have movement of an arm, movement of a leg, any movement artifacts throughout the body you'd want to select. Obviously, completely customizable. So anything you want to add, you're free to define it as you wish. And you can select and deselect these anytime throughout the data collection. Okay, once you've done your data collection, the last thing, your data will be automatically uploaded onto the cloud, which will be securely locked with your password, username. Have some more information on this in a moment. But for now, in the top right-hand corner here, you can see the little folder icon. You can click here and check that your data has been uploaded and collected properly before you have to go into your account. So that's it from here. I'll pass back over.
Thank you very much, Sophia. Let me share my screen again. So we have looked at the functionalities of the app for logging inside, connecting the classes via Bluetooth, looking at the feed status and getting any error or feedback. We've also been able to set up new studies and set up the parameters for those, including the definition of the participants and the task and the labels. But what we haven't looked at is the data collection and storage and the automatic upload on the cloud, which I'm going to show you now. So once you have collected your data, the data is automatically stored onto a password protected AWS storage. You can register with your login and you can have access directly to all the data sets that you have saved through the app. This allows you to look inside your folder, which is organized based on the project and the type of study and task. And in there, you can manage your data files, you can download, you can also delete them as you wish. How does the data look like? Quick dive into that. You can find detailed information on our documentation that's becoming actually public very soon. The sensor data are saved into a CSV file where each column has a different data stream. And every header is added on top of the column to signify which data stream that is. So we have, for example, the Unix timestamps to synchronize all the data streams together. We have the sensor output for the IMU. We have the rotation. We have the navigation sensors and the proximity sensors. And for each one, you have the location of the sensor included within, so right cheek, left cheek, etc. We also have pressure output. And at the end of the CSV, you will see added as individual columns every algorithm that you have selected as part of the process for the task creation in the app. So that will be all stored together along with labels and any other tags that you may have added. So all in one. And so with that, I think we conclude our quick webinar. We will go ahead and take some time for questions now. So just a reminder that please be sure to type your questions into the question box in your control panel. And then we will start going through those. Okay, so what happens with the battery and how do I make sure that it's always on?
So with the battery, if the battery starts to go below sort of 20%, the glasses will provide a haptic feedback to the user. So the user knows that they need to go and at that point start charging the glasses. Otherwise, it will start to cut off at some point. What the indication is sort of gives them enough time to finish whatever data collection they're doing at that point and have enough time to go back and charge it without stopping their data collection.
Thank you, Mohsen. Another question. A haptic feedback sensor is provided. Can you explain what it does?
The haptic feedback is simply the same as the vibration feedback that you get from any mobile phones or any other devices. We have a vibration motor there, and also we have LED lights, RGB, to provide various statuses.
What happens to the data if the connection is cut midway during the data collection?
So that would be a state where, for example, there is an issue with the Bluetooth connection. That is, for example, when a user is moving further away from the iPad, for example, to a different room, and the data collection won't be stopped immediately. The glasses will auto reconnect as soon as the person's back inside the room. So the data collection can carry on as soon as they come back.
Do the glasses come in different sizes? Have they been tested on young people and children?
So currently the glasses are designed to fit into two kind of sets of narrow and wide faces. We haven't done testing on children, but based on our sizes, they are slightly larger for children.
Are they suitable for commercial applications?
It depends on the setting of the application, but the data collection view that we provided can be very helpful. Also, we provide various sort of analysis for the data, but it comes down to the type of application you would like to run, and we will be very happy to discuss any specifics. You can reach us through our website or any other sources, and we can provide a specific analysis for you.
Perfect, thank you very much. We have a few more to go through. If I've set up my study, can I save the variables for another time?
Yes, so within the app, once you've created a study or a project, that is saved on your user. So you can access it whenever you log in. Similarly, your participant data will be stored there as well. So you can go into a participant and collect more data with them or add more tasks.
One more information related as well to the information we put in the app is there any identifiable information or in parentheses images that goes in the cloud?
Yes, so files will be saved with the name that you put on the task or on the project, well, both. So there's not necessarily images, but the title of the task will be under the participant first, and then the title of the activity that they're performing. So you'll be able to search through that as well by participant and then download all of one participant's data. It's quite easy to navigate.
And also, if any part of the data has been uploaded wrongly, or you have uploaded any videos that included images, you can delete those from your own login.
Okay, it looks like we've covered all of the questions. So Mohsen and Sophia, is there anything else you wanted to cover before a wrap up?
I just wanted to add that if you go to our website, we have our white paper under, and also lots of kind of publication that we have done working with these glosses and showing how the data could be used and how it could be analyzed. There's a lot of information there if you're interested.
Exactly. There's also our work and our research that we've done over the last years with EMT, but it's also the long history of research and literature work that has been done in the past with the MGS basis. And now that we're moving into the OMT, we have leveraged all that information into our design and our algorithms and how the systems work. So anything from your side as well, Sophia, that you wanted to cover?
Just obviously that's past research, moving into future research. We are looking to work with researchers and would be able to come up with some kind of offer or discount for them for the sale of the glasses.
Exactly. So I was going to say as well that we are opening our beta scheme for researchers. We have an apply now button to on our website on the OCOsense page, emteqlabs.com/OCOsense. And from there, we're going to look at the suitable programs and projects. And we're going to offer a discount from 20% to 100%. Please let us know if you're interested. If you want to get in contact with us, please email us on info@emteqlabs.com. A big thank you to my co-presenters here, Mohsen and Sophia, and to everyone else that has attended our webinar. Thank you very much for the questions as well. We appreciate everyone being here. We just want to let you know that the system is now launched for pre-orders this week, and we'll be announcing more features on our website and our social media. So if you want to support us, please follow us there and subscribe to our newsletter if you haven't done so. Again, thank you very much for joining us today. We'll see you next time.